See, last class I explained about the grooving operation. So, how to make an external groove on a cylindrical object by using a CNC turning center. So, I explained one problem, so how to make a groove, and other problem I given one assignment. So, you need to practice that problem. Now, in today's session, we will see how to write a program, turning program for external thread cutting operation. So in thread cutting, you have two different categories. One is external thread cutting and internal thread cutting. So internal thread cutting operation is known as tapping operation. I think you are aware about tapping and how to make a tapping for hollow cylindrical object. So that is another part. So we will see how to make the thread cutting operation. This is a last operation in CNC turning. So how to make a thread cutting operation by using CNC turning center. So that is a last topic. This is the last topic in SimLab. So maybe today I will complete the today's session. I think 1 minute. I will start. I will share the screen. Yes, may I audible? Yes, Chetan.
Yes, sir. Audible, sir.
So what about the screen? Can you see the screen?
Yes, sir.
Yes, sir. Okay, fine. I'll start the session. See, okay. So in this is the given problem. So we need to write a CNC part program for the given profile. Okay, so in this profile is given different operations like you have a plane turning is there, and some step turning operation is there, and you have grooving is there. Okay, some grooving is there, and also you will find some thread cutting operation is given. Okay, so thread cutting is given, the thread length is given 50 mm, and major diameter is given 32, and M32 into 2.5 means major diameter is 32 and pitch is 2.5 mm is given. Okay. See, in this for this problem, we need to write a CNC part program for this problem. So initially, we need to write the program for rough turning operation. So that is by using G71 cycle. I already explained. So in this problem is given rough turning operation, grooving is there, and thread cutting operation is there. So totally we have to perform, we have to use three different CAN cycles. So one is rough turning cycle, that is G71 cycle, and we have to use grooving cycle, and the next one is external thread cutting cycle. See, if the image is not visible, I will share the image through WhatsApp, so you can use that image if dimensions are not visible properly. Okay. So in this case, before explaining thread cutting operation, let us see what will be the syntax, and there will be some few calculations. So we need to follow few calculations with respect to thread cutting operation. If you know the calculation part, it's very easy. It's very easy to write a CNC part program for the thread cutting operation. So now we will see what will be the calculation part for external thread cutting operation. So now I'll
ಬಸವರಾಜ ಸರ್ ಸಿಕ್ತಿಲ್ಲ, ಅವ್ರೇನಂದ್ರು ಅಲ್ಲೇ ಅನ್ಲಾಕ್ ಮಾಡ್ತಾರೆ ಹೋಗಪ್ಪ ಅಂತಂದ್ರು. ಅವ್ರೇನಂತಾರೆ ಹೋಗಿ ಕ್ಲಾಸ್ ಟೀಚರ್ ಅನ್ಲಾಕ್ ಮಾಡ್ತಾರೆ ಅಂತಂದ್ರು. ಕ್ಲಾಸ್ ಫೀಸ್ ಕಟ್ಬಿಟ್ಟಿದ್ದೀನಿ ಇವಾಗ, ಕಂಪ್ಲೀಟ್ ಫೀಸ್ ಆಗೋಯ್ತು ಅಂತ.
ಕ್ಲಾಸ್ ಟೀಚರ್ ಹತ್ರ ಎಲ್ಲಿದ್ದಾರೆ
ಬಸವರಾಜ ಸರ್ ಕಾಲ್ ಕಟ್ ಮಾಡ್ತಾರೆ, 2 ಸತಿ ಮಾಡಿದೆ. ಮತ್ತೆ
ಅವ್ರು ಇದ್ದಾರೆ, ಅವರು ಮೇಲೆ
ಮತ್ತೆ ಮೇಲೆ ಫುಲ್ ಸಿವಿಲ್ ಡಿಪಾರ್ಟ್ಮೆಂಟ್
ಕೆಳಗಡೆ ಲ್ಯಾಬ್ ಸೆಷನ್ ಇವತ್ತು.
ಅವ್ರಿಗೆ
ಎಲ್ಲರಿಗೂ ಲ್ಯಾಬ್ ಇವತ್ತು, ಕೆಳಗಡೆ ಲ್ಯಾಬಲ್ಲಿ ಇರ್ತಾರೆ. ಅವ್ರು ಏನಿಲ್ಲ, ಜಸ್ಟ್ ಒಂದು ಈ ವಾಟ್ಸಪ್ ಮಾಡಿದ್ರೆ ಅವರು ಅನ್ಲಾಕ್ ಮಾಡ್ತಾರೆ.
ಸದ್ಯ ನನ್ನ ಹೆಸರು
ಕ್ಲಾಸ್ ಟೀಚರ್,
ನನ್ನ ಹೆಸರಲ್ಲಿ ಬರ್ಕೊಂಡಿದ್ದೀನಿ ಲ್ಯಾಬ್ ಬೆಳಗ್ಗೆ. ನಾನು ಅದಕ್ಕೆ ನಾನು ಓಡ್ ಬಂದು ಕಟ್ಟಿದ್ದು. ಈಗ ಅಟೆಂಡೆನ್ಸ್ ಅಲ್ಲಿ ನನ್ನ ಹೆಸರು ಹಾಕೊಂಡಿದ್ದೀನಿ, ಸಾಗರ ಸಚ್ ಅಂತ.
ಎಲ್ಲಿ ಅದು ಇಲ್ಲ ಇನ್ಕ್ಲೂಡ್ ಆಗಿಲ್ಲ ನನಗೆ.
ಅದೇ ಸರ್, ಹೆಂಗ್ ಲೆಕ್ಕ ನೋಡೋದು?
ಈ ಕ್ಲಾಸ್ ಟೀಚರ್ ಹತ್ರ ಹೋಗು, ನಾನು ಒಂದು ನಂಬರ್ ಕೊಡ್ತೀನಿ, ಆ ನಂಬರ್ಗೆ ನೀವು ಕ್ಲಾಸ್ ಟೀಚರ್ ಮುಖಾಂತರ ಒಂದು ಮೆಸೇಜ್ ಹಾಕ್ಸು. ಸೊ ದೇ ವಿಲ್ ಅನ್ಲಾಕ್. ಓಕೆ, ವಾಟ್ಸಪ್ಪಿಂದ ಹಾಕ್ಸಿ ಮೆಸೇಜು.
ಓಕೆ ಸರ್, ನಂಬರ್ ಕೊಡಿ ಸರ್.
ಏನಪ್ಪ,
ಆಯ್ತು ಸರ್.
ಕುಮಾರ್ ಅಂತ.
ಓಕೆ ಸರ್. ಇವರು ಬಿಳಿ ಕುಮಾರ್ ಮೇಲೆ ಇರ್ತಾರಲ್ಲ, CS ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಅಲ್ಲಿ. CS ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಮೂಲೆಗೆ ಇರ್ತಾರಲ್ಲ, ಆಯಪ್ಪ ಹತ್ರ ಹೋಗ್ಬೇಕಾ?
ಕ್ಲಾಸ್ ಟೀಚರ್ ಮುಖಾಂತರ SMS ಹಾಕ್ಸೋ, ಇಮೇಲ್ ID ಮತ್ತೆ ಇದು ಫೀಸ್ ರಿಸಿಪ್ಟ್.
ಓಕೆ.
ಸೊ ಆಟೋಮೆಟಿಕ್ ಆಗಿ ನಾನು ಲಾಸ್ಟ್ ಟೈಮ್ ಥರ್ಡ್ ಸೆಮ್ ಎಲ್ಲ ಮಾಡಿಸ್ತೀನಿ.
ಕುಮಾರ್ ಇರ್ಬೇಕು ಬಿಡಿ, ಮತ್ತೆ ID ಕುಮಾರ್ ಅಂತ ಹಾಕೋದು.
900 ಚೆಕ್ ಮಾಡು. 900
ನಿಮಿಷ 900
81 06
361. ಇಲ್ಲ ಬಿಡಿ, ನಂಬರ್ ಇಲ್ಲ. 9008106361.
361. ಅವ್ರಿಗೆ ಕ್ಲಾಸ್ ಟೀಚರಿಂದ ಅವ್ರಿಗೆ ಒಂದು ಮೆಸೇಜ್ ಹಾಕ್ಸು. ಸೊ ಅವ್ರು ಅನ್ಲಾಕ್ ಮಾಡ್ತಾರೆ, ವಾಟ್ಸಪ್ಪಲ್ಲಿ ಹಾಕ್ಸು.
ಥ್ಯಾಂಕ್ ಯು ಸರ್.
ಇಲ್ಲಾಂದ್ರೆ ಕಾಲ್ ಮಾಡಿ ಕೇಳು. Okay. So now I'll explain about the G76 cycle or external thread cutting cycle. So it is G76 cycle. This is also known as the external thread cutting cycle. Thread cutting cycle. So now, what is a G76 cycle and how we have to use this cycle to write a CNC part program. Okay, am I audible? Now I'll go to the general syntax for G76 cycle. So G76 cycle is, so I'll write syntax before explaining G76 cycle. So G76 cycle, so then we need to write p value, and this p value should consist of 6 digits. So I'll write 1, this is 6 digits, that is 1. The second digit, third digit, and fourth, fifth, and sixth digits. So P consists of 6 digits. I'll explain what is first digit indicates, what is second, what is third, what is fourth, what is fifth, and what is 6 digits indicates. So that is the P value, and you have Q value. So I'll explain what is Q value, and you have R. We are calling as a horse. So this is the first line, and in the second line again I will go to G76, and we need to enter what is the X value, we need to enter what is the Z value, and we need to enter value, and we need to enter. First one is we need to enter what is the F value. So this is a syntax for G76 cycle or external thread cutting cycle. It's very important. You need to remember this syntax. Suppose if you not remember, it's very difficult. So you need to remember these syntax before writing any part program by using G76 cycle. Okay. So now okay, now I will explain what is P indicates, what is Q indicates, what is R indicates, what is X, what is Z, what is P, what is Q, and what is F. Okay. So in the first block, see, in the first block means you have a P value. So I'll write it as a first block. The first block. See, first block means what is that P? So I told P consists of 6 digits. Generally the P consists of 6 digits. So here the first digit, first and second digit. Let us see the first and second digits indicates number of passes. Say it is first and second digits indicates first and second digits indicates number of finishing passes. We'll see what is finishing pass. Number of passes. See, generally while performing thread cutting operation, so at the end we need to enter what will be the finishing. So generally how many passes you are taking to complete the finishing operation in external thread cutting operation. So that is first two blocks. In the first block, P first and second digits indicates number of finishing passes. So that is the first one. Again in the P, third and fourth digits indicates. So next I will go to third and fourth digits. Third and fourth digits digits indicates chamfer angle. That what is chamfer angle for the threads. So that is the third and fourth digits. Chamfer angle. Generally, we need to assume the chamfer angle. Say assume the chamfer angle, you can assume say 5 degree. So for 5 degree means you need to write 0.5. Suppose chamfer angle, if you are assuming 15 degrees, you need to enter 1.5. That is the third and fourth digits. So that is the chamfer angle. Similarly, I'll go to the next one is we go to the last two digits, that is fifth and sixth digits indicates thread angle. Fifth and sixth digits. Fifth and digits. Fifth and sixth digits indicates thread angle. In the exam, if not mention these parameter, you need to assume. You need to assume what will be the chamfer angle of the thread. Let us assume chamfer angle is say 5 degree, 4 degree, or 7 degree, or 8 degree will be the chamfer angle. So that is a 0.8, 0.5 degree, or 0.4 degree. And last fifth and sixth digits indicates the thread angle. Let us assume the thread angle is say 20 degree or 25 degree or 30 degree. So generally in the exam you won't specify, so we need to assume these parameters. So this is the G76 first in the first block P value. So I told the P value we need to specify 6 number of digits. So first 2 digits indicates number of finishing passes. Let us assume finishing passes is 02 or 03 or 04. And the third and fourth digits indicates chamfer angle. Let us assume chamfer angle is 0 degree, or let us assume the chamfer angle is 01 degree or 02 degree or 03 degree. So that is the chamfer angle. And fifth and sixth digits indicate the thread angle. Let us assume the thread angle is, these are the assumption we need to assume, or in the examination if you specify, you need to use that particular value, or else you assume these values. Okay, so this is about P value in the first block. So next I will go to the next value V's. Let us see the next value is I will take a Q value. What is Q indicates? What is Q indicates in the first block itself. I am not moved to second block. In the first block, the Q indicates minimum depth of cut. So what will be the minimum depth of cut? What will be the minimum depth of cut in terms of microns? So we need to specify in terms of microns. Say minimum depth of cut, I am assuming let us take 100 microns or 250 microns or 300 microns. So these are the minimum depth of cut in terms of microns. So that is a Q value. So next you have one more value called R. Finishing allowances. Finishing allowances. So this is finishing allowance. Okay, in terms of mm. So this is in the first block. Then if you go to the second block, second block of external thread cutting cycle or G76 cycle. So that is second block. The second block. I move on to second block. So this is first block. See, this is indicates first block. In the first block, these are the values. Okay. And next I'll move on to second block. So in the second block, the first term is X value. So you will see what is X value. You will see what is X value in the first block. So X value. So X value is core diameter. X value is core diameter. So I'll explain what is core diameter and how do you calculate this core diameter. Core diameter means a diameter up to which thread must be cut. Core diameter means diameter up to which the thread must be cut. So we have formula. We have some formula to calculate the core diameter. So core diameter you need to remember this formula. X is equal to, you have a formula, X is equal to major dia minus 2 times of pitch. So major dia, major diameter minus 2 times of pitch, 2 into thread pitch. So 2 into, sorry, you have 2 into thread pitch. So I'll go to thread pitch. So remember this formula to calculate the core diameter. So we need to calculate what is the X diameter. X nothing but major diameter. So major diameter in the problem is given M32 into 2.5 is mentioned. So M32 means it's the major diameter is 32 mm and 2.5 will be the pitch. Substitute these values and simplify. So you will get X value. So that is the X value. Then again, if you go to the Z value. So next, if you go to the next, we have a Z. What is Z? So next, I'll go to the Z value. So Z indicates length of thread from the reference. So we need to take length of thread from the reference, thread length. Let us take thread length. Thread length in terms of mm, and you need to assume this thread length from the reference. Always we need to take from the reference. So don't take only thread value. You have to assume Z value from the reference. So that is a thread value. So then after that we will go to the next one is I will go to P value. So now we will see what is P. So P is, so P nothing but height of thread in terms of microns. Height of thread. Height of thread in terms of microns. So how do you calculate height of the thread? P nothing but it's the height of the thread in terms of microns. You need to keep in terms of microns, not in terms of mm. Okay. So now P should be equal to, so height of thread P should be equal to, P is equal to pitch into, remember the formula, thread pitch. Pitch into pitch into you have 0.61343. Okay. So you will get in terms of mm, because pitch we are substituting in terms of mm, therefore you will get P value in terms of mm. So you need to convert into micron, just multiply by 1000. By multiplying 1000 value you will get mm into microns. Okay. So here so next I will go to the next concept is you have last one is Q value. So what is Q? Q in the second block. Q in the second block is maximum depth of cut in terms of micron. So this is maximum depth of cut in terms of microns. Then last term is you have F value. So F nothing but it's a feed rate. The feed rate in terms of mm per minute. So this is the complete calculation part for G76 cycle or external thread cutting cycle. It's very important. It's very important. You need to remember this concept. If you know what is G76 cycle along with the calculation part, it is very easy to write the program for thread cutting operation. So generally in the examination you will find a combination of G71 cycle along with grooving cycle or G71 cycle along with G76 cycle. You may get any combination, thread cutting and rough turning or grooving and rough turning. So these types of combination problems you will see in the examination. okay, or in the internals, okay. So I'll repeat, what is G76 cycle. See, G76 cycle is a CAN cycle used to perform thread cutting operation, or it's a CAN cycle used to perform some specific operations, and the specific operation is external thread cutting operations, okay. So now this cycle says that you have G76 and P. P is followed by 6 digits number. Say assume you have first 2 digits indicates number of finishing passes. Let us take the finishing passes is 05. So we need to write 05. So while solving the problem, you get to know how we have to enter what is P, what is Q, what is R, and in the second block exact PQF. While writing the program, you will get to know. Okay, and similarly third and fourth digits indicate chamfer angle. See, these are the assumptions you need to assume. The examination, they won't give any chamfer angle, they won't give any number of passes or thread angle. You won't specify anything. You need to assume those parameters. Okay, and fifth and sixth digits indicates fifth and sixth digits indicates fifth and sixth digits indicates the thread angle in terms of degree, okay. And Q is a minimum depth of cut in terms of microns. See, in the first block and second block you have Q terms. So minimum depth of cut in the first block. In the second block you need to write maximum depth of cut. So always maximum depth of cut should be greater than minimum depth of cut in terms of microns. And our the finishing allowance we are giving in terms of millimeter. Then second block G76 X nothing but core diameter. We need to calculate core diameter by knowing the major diameter. Major diameter is given, so that core diameter is equal to major diameter minus 2 into thread pitch. Thread pitch is also known. So in this problem it is 2.5 will be the thread pitch. So then Z value is thread length. Thread length in terms of Okay. Generally, Z value we need to measure from the reference. From the reference, you need to consider the thread value. So then go to the next P value is thread height in terms of micron. So the thread height can be calculated as pitch into 0.61343. We'll get in terms of converted into microns. Okay, so that is a thread height. So then Q should be in terms of maximum depth of cut in terms of microns, and F will be the feed rate in terms of mm per minute. So this is a complete calculation part of external thread cutting operations. So this is external thread cutting operation. Remember these concepts. Remember these concepts. So now I will start writing the part program for this profile. May I audible? Yes, anyone?
Yes, sir.
Yes, sir.
Fine. So now I will, before writing any part program, we need to assume blank or raw material dimension. So now I'll go to raw material. I'll assume raw material dimension. So let us take this is raw material. So I'm taking raw material dimensions. I assume this is raw material. Okay. This is raw material, or it's a blank. So this is blank, or we are called as billet. Generally we are calling as a billet. Let us take it's a billet and consider some dimension. What is the dimensions of the billet? Okay. So in this case I'll assume some dimensions. So assume what will be the x and what will be the z. So in this case x nothing but is with respect to diameter. So maximum diameter of the part is given, some 63 is given. So let us take the maximum diameter. In this problem is given 63. So I will take 65. 65 will be the maximum diameter of the workpiece. Okay. And similarly, let us go to the Z value. So Z nothing but is what is the total length of the part. So total length of the part is you have 50, then 5 plus 5, so that is 60, then 52, 60, 70, 80, 90, 100, 110 and 102. Let us take 120. Let us take 120 This is assumption. I am assuming this billet size. mm will be the dimensions of the billet size. Okay, so X I am assuming 65 and Z I am assuming 120 mm. So this is the billet size. So next one is we need to calculate the dimension. So what will be the dimension? What will be the coordinates? We need to consider the coordinates. So now I will go to the coordinates. So let us take the coordinates. So I will go to coordinates. So assume this is axis. I'll go to the axis. Okay, so this is the axis. So now we need to assume some of the parameters. So we need to assume. So we need to assume some of the dimensions. Let us take the dimensions. At this point, I will call it as 0. Okay. So on e dimensional and 0 anta tagonತೀನಿ. Let us take this dimension will be the 0. Okay. Or we can say it's a 0, 0. Or we can take it's a 1. It's fine. This is a 1. And this point, this coordinates, I will take point number 2. And here, I will take point number 3. Then this corner, I will take point number 4 and 5. This is 4, and this one I will take 5, and this one I will take 6, this bottom one I will take 7, and above I will take 8, and this one I will take 9. Okay, so these are the coordinates. So these are the coordinates we need to calculate. We need to calculate what are the coordinates at various points. So now I will calculate what is the coordinates at point 1, point 2, point 3. Okay. So now let us go to point 1. So point 1, it's a reference. It is 0, 0. This is 0, 0, coordinate number 1. Let us go to second point. Second point, the coordinates are x and z value. X means with respect to diameter and z means with respect to length. For second point, M32 into 2.5 is given. M32 means it is a major diameter. So major diameter is given 32. You need to consider 32 only. So it should be 32 will be the x and z will be the 0. Next, similarly, go to point number 3. Go to point number 3. So at point number 3, again major diameter is given 32 mm and z is given minus 50. It should be minus 50 from the reference. Well, I took 0, 0 will be the reference. Next, I go to point number 4. I go to point number 4. The coordinates diameter. So diameter at point number 4 is, I think it is 36. It is 36. Coordinates at point number 4 is 36. It's not 32. It is 36, comma, and z value is 50 plus 5. That is minus 55. Minus 55. Then go to fifth one. Coordinates at point number 5. Again, diameter is 36 and length is 50 plus 5 plus 5. So that is 60. So minus 60. It should be minus 60. So then I'll go to the next one is point number 6. I'll go to point number 6. At point number 6, the diameter is, I think it is a 55. Diameter is 55. So in the image is not visible. I will share another image. So diameter is 55 and length is at point number. This is at point number 6. the length become 50 plus 5 plus 5, so that is minus 60, minus it is minus 60. Next I'll go to point number 7. So the diameter is again it is 55. 55 will be the diameter, and the length is at point number 7. The length is 50, 60, 70, 80, 82. So this is minus 82. Okay. So this is minus 82. So then next one is I'll go to point number 8. At point number 8, the diameter is maximum diameter is 63. Diameter is 63, and the length become minus 82. It is minus 82. Okay. Next I'll go to the last one is point number 9. So I'll go to point number 9. So the diameter is same 63, and the length is it's a minus 82 plus 30, 102. So it is 102. Okay. So minus 102 will be the Z value at point number 3. Okay. So this is 50, 50, 60, 90, 102. So I took the Z value is 120. Okay, it's fine. It is not a
It's not
problem.
102, sir. It's 112, sir.
Is it 112? Okay, I will take 112 means 50, 60, 70, 80, 90, 100. Yes, 112. Fine. It is 112. Okay. So I took Z is 120 mm. Okay. So these are the coordinates. So first thing is in the examination, you need a diagram will be given. So for the given diagram, first identify the coordinates. That is the first thing. Then identify what are the list of operations you need to perform. See here in this problem, we need to perform different operations. So I list out the different operations. The first one is you need to use G71 cycle. You need to use G71 cycle. 71 cycle is known as rough turning. Known as rough turning cycle. So this is rough turning. Rough turning means we can perform step turning, plane turning, and we can perform step turning, plane turning, and even some other operations also we can perform by using rough turning cycle, like plane turn, step turn, and taper turn. So those operations we can perform by using G71 cycle. So after completion of G71 cycle, now look at the coordinates from 3 to 4. 3 to 4 is there will be a groove is given. Groove is given between coordinates 3 and 4. So we need to perform after completion of G71 cycle. The next thing is we need to perform G70. What is the grooving cycle? What is the grooving cycle? Yesterday we solved one problem. What is the syntax for grooving cycle? What is grooving cycle? It is G75 cycle. Grooving cycle is G75. So now it is G75. G75 cycle, that is grooving cycle. Grooving cycle. We need to perform grooving cycle. So that's the second operation. Next, third operation is we need to perform thread cutting cycle. That is G76 cycle. G76 cycle is on a thread cutting cycle. So these are the operations you have to perform. These are the operations you need to perform for this profile. Okay. So now we will see the program. How to write the program for this profile. See, generally in the examination, you can expect either G71, G75. You will find the combination of G71, G75 or G71, G76. See, G71 is common. If you take any profile in turning, you need to use G71 cycle or rough turning cycle like plain turn, step turn, and taper turning operation. So that can be done with the help of G71 cycle. So then after that you may find either G75 or G76. Either it may be a grooving or it may be a thread cutting. Or in some cases you may ask all types of cycles like G71, G75, G76 depending upon the type of the problem you will get in the examination. So now I'll start a program. See, before writing any part program, you need to write the program name. You need to write the program name before starting any part program. Let us see that program name. So now, okay, 1 minute. Okay. So before writing any part program, you need to specify the program number. So I will call program number. I'll use program number is some letter along with some number. Say assume 1, 2, 3, 4, 5. So this is the program number. Okay. So after writing the program number, so next step is you need to specify the billet. So what will be the billet? Billet dimension. So I will specify the billet dimension is, how do you represent a billet? So I think so we need to specify the billet or billet dimension. So this is a billet of dimensions x and z value. See, x we assumed 65 and z we assumed 120 mm. So this is the billet size. So we need to specify the billet size before writing any part program. So then next step is I will write the block number. Say I will go to block number. Say N01 will be the block number 1. See, while writing the for this profile, first I am writing a program for G71 cycle or rough turning cycle. While writing G71 cycle, don't consider the groove and thread cutting. Don't consider grooving and thread cutting while writing the program for G71 cycle. Okay, so now I will neglect the thread and I will neglect the groove. Then I will complete the G71 cycle. Then we will see the remaining. After that, we will see G75 and G76. So now block number is N01 will be the block number 1. So next, after writing N01, look at the dimensions. See, all dimensions are given in terms of metric. Metric means all dimensions are given in terms of mm. So I will use G21. I already explained G21. So next, suppose if dimensions are given in terms of inches, use G20. So next I will go to feed rate. So feed rate I am assuming in terms of mm per minute. I will assume the feed rate in terms of mm per minute. So therefore I will use G98. G98 means feed rate in terms of mm per minute. Suppose if it is revolution, we have to use G99. So use G98. Okay. So now next step is I will reset the tool position in tool turret. Tool turret is a device where we can store the tools, single point cutting tools in a CNC machining center is known as tool turret. So now I will send the tool to its own portion. Say N02, G28, U0 and W0 are the secondary movement of tool with respect to X and Z directions. U and W are secondary movement of tools with respect to X and Z direction. So that is G28. So next I will go to N03. I will go to N03. So generally before performing any machining operations, you need to switch on the coolant, we need to switch on the spindle and you need to specify the spindle speed. So now I will switch on the coolant. So switch on the coolant, I will use M08, will be the coolant on, and the spindle speed. Say assume I will switch on the spindle in clockwise. So I will use M03. Spindle on in clockwise direction, and the spindle speed I am assuming, say assume the spindle speed is 1700 will be the spindle speed. So that is S700, 1700. So next, I'll go to the next block N04. So now we need to select the tool to perform rough turning operations like plane turn, step turn, or contour or taper turn. So those operations, to perform those operations, we need a single point cutting tool. So now I'll select the tool M06. M06 means tool select or tool change. M06, I am using tool number is T01. So T01 will be the tool number I am using. Okay, so that is T01. So next I'll go to N05. I'll go to the next block N05. So next is very important. Now this concept is very important. So here we need to specify the start point of the tool, which is the start point of the tool before performing G71 cycle or rough turning cycle. So initially I will bring the tools here. I will bring the tool directly from here. Just look at the cursor. So tool somewhere here, I select the tool from the tool turret. So say assume the tool turret somewhere is here. So I'll bring the tool from tool turret to this edge of the workpiece, or we can say it's a corner. It's one of the corner, top corner of the workpiece. There I'll bring the tool. So while moving the tool from tool turret to this corner of the tool, we have to use G00. While moving the tool should not do any machining operation. So that is rapid movement. So it is G00. I am moving the tool from tool turret to, so this corner. Let us take this corner. This corner means somewhere here. See, workpiece is like this. Somewhere here I will move the tool. So that point I will call it as this corner. Or else if you want, you can maintain a small gap between the tool tip and the work surface. So that is also fine. So now I'll move the tool rapidly using G00, and the coordinates at that points are X is 65, X will be the 65, so diameter is 65, and Z is 0, or you can maintain 1 mm. Let us take 1 mm or 0 is also correct, 1 mm is also correct. So even if you are doing in front of CNC machine, generally a programmer should maintain a small gap between the tool tip and the work surface before writing any part program. So anyhow, you are doing simulation kind of work. So even if the tool tip touches the work surface, it won't affect the part program, or it won't affect the tool geometry. It won't affect the workpiece geometry. Okay, so this is a rapid movement of the tool. So next step is I will use the syntax. I will use G71 cycle or rough turning cycle. Okay. So now G71 cycle. So I'll use G71 cycle, and you remember the syntax. U is finishing allowance. I am assuming 0.5 will be the finishing allowance. I am assuming, let us take 0.7. These are assumption. Retract, I am assuming 0.7. Next I will go to N07. I will go to N07. Again G71. You need to specify. P will be the starting block number. Say after N07 we are I am writing N08. So that will be the starting block number, N08. And Q is unknown. I don't know where the program ends for G71 cycle. That is the Q is unknown. G71, PQ, then U, W and F. U is finishing allowance in X direction. I am assuming 0.01. That will be the U. And W means it is a finishing allowance in Z direction. That is 0.01. I am assuming. And let us assume the feed rate. Feed rate for G71 cycle, let us assume some 120 mm per minute will be the feed rate for this cycle. Okay, so now I'll go to the next block N08. I'll go to the next block N08. So now as per these instructions, tool is here, somewhere here, tool is here. So now no need to bring the tool from here to 0, 0 because it is a complete, it's a flat. So I'll move the tool rapidly from, not rapidly. I'll move the tool by using G01, rapid movement, not rapid, it's a linear interpolation. Linear interpolation means we have to use G01. linear interpolation. So now the tool is at point number 2. The tool is at point number 2. So point number 2 means coordinates. The tool is at coordinate number 2, that is 32 and sorry, it is not 32. The tool is at 65 comma 0. So now I will move the tool from 65 comma 0 to coordinate number 2. Even if you want, you can move to 0 comma 0, then you can move from 0 comma 0 to 32 comma 0. So instead of moving 0 comma 0 to 32 comma 0, so directly I will move the tool from 65 comma 0 to 32 comma 0. That is, I'll start from the second point. So now coordinates are x becomes 32 and z becomes 0. Let us take z is 0. So next I'll go to n09. I'll go to the next block n09. So now tool is at point number 2 or coordinate number 2. So now I'll move the tool from 2 to 3. I'll move the tool from 2 to 3, or else if you want, you can move the tool from 2 to 3 I will move. Okay, so first I will go to it is G01. It is G01. The diameter is again same 32. Diameter is 32. See, Z value is, see, from 2 to 3 is 50. After that we have 5 mm extension. So in 5 mm extension, there is no, you will not get any taper, or you will not get any step. So directly I will take Z value is 50 plus 5. I will take 55. 50 plus 5, I'll take 55, or else you can move from to 50, then again you take 5 mm, then again go upward, because 3 and 4 is different. The diameter at coordinate number 3 is 32 and diameter at coordinate number is 36. It will not be a flat, it will be some step is given. Okay, so that's why I'll move the tool from 2 to 3, then 3 to that corner, edge corner, then go upward. Okay, so now here x is 32 and z I will take 50 plus 5, directly I will move. So totally I will take 55 mm. Don't look at the coordinates. Okay, so this is as per my convenient. I will move the tool like this. So now I will go to the N10. I'll go to N10. Again it is G01. No need to specify G01. So now we need to move the tool upward. That is coordinate number 6. So coordinate number 6, x will be the 36. So like x will be the 36 and z remains same. Okay. So next I go to N11. Now tool is at point number 4. So I'll move the tool from 4 to 5. 4 to 5 is x become 36 and z become minus 60. Z is minus 60. That is coordinate at point number 5. Z is minus 60. So next I'll go to N12. Now tool is at point number 5. Tool is at point number 5. So I'll move the tool from 5 to 6. 5 to 6 is linear interpolation. So 5 to 6 enter only coordinates. It is G01 and coordinates. G01 and coordinates are at point number 6. The coordinates are 55 and it is minus 60. 55 and minus 60. So next I'll go to the N13. Now the tool is at point number 6. So I'll move the tool from 6 to 7. It is linear interpolation. The coordinates at point number 7 is 55. Z become 82. So next I'll go to N14. So now tool is at point number 7. So I'll move the tool from 7 to 8. 7 to 8 is a linear interpolation. So enter the coordinates. Coordinates at point number 8 is 63 and z become minus 82. So next I'll go to the next block N15. So next tool is at point number 8. So now I'll move the tool from 8 to 9. So 8 to 9 is a linear interpolation. So we need to enter G01 and coordinates, x and z coordinates. So in here G01 no need to enter because it is repeating. Same linear interpolation is repeating for every previous cycles. I'll enter only coordinates at point number 6, sorry, at point number 9. So at point number 9, the coordinates are, so here x is 63 and z become minus 112, minus 112. So now I completed the profile. So now the Q value is 15, 15. Q is 15. It's very important. If you not specify Q value, you will not get the output. Anyhow, you will not get any simulation. Okay. So now I completed G71 cycle. So next step is you need to perform a grooving operation. Say first perform grooving operation, then go for thread cutting, or first you can make thread cutting, then you go for grooving operation. Generally, I will follow this procedure. So first I will make rough turning, then I will go for grooving, then I will go for thread cutting operation. Okay, G76 thread cutting operation. So next is we need to change the tool to perform grooving operation, or after changing the tool make a grooving operation. So now I will change the tool, or I will send the tool to its home position. First send the tool to its home position and call new tool. That is a procedure we need to follow. So now I am sending this tool G28 U0 and W0. So I send the tool to its home position or tool turret position. So next I'll go to the next block N17. I'll go to the N17 and now call new tool. I need one more tool to perform grooving operation. So select the tool. Say tool selection is M06 will be the tool selection, and enter the tool number. Say I need tool number 02. 02 nothing but it's a grooving tool. So I am using grooving tool. Okay. So next one is, now the next step is identify where is the start point of the groove. Just identify the start point of the groove. So my start point of the groove is at point number 3, or at coordinate number 3 will be the start point of the groove. So between 3 to 4 we need to make a groove, from 3 to 4. So my start point is coordinate number 3 will be the start point of the groove. So now I will move the tool rapidly. I will move the tool rapidly. That is G00. I will move the tool rapidly from tool turret to coordinate number 3. I will move the tool rapidly from tool turret to coordinate number 3. So coordinate number 3 is 32 and 50 is given. So I will maintain a small gap. Okay, I will move the tool rapidly. So from tool turret to point number 3. So point number 3 coordinates are x is 32 and z is minus 50. Okay, or else you can maintain a small gap. So remember, the tool should not touch the workpiece, so that's why I maintain a small gap. Even this is also correct, and even if you make 33, that is also correct. If you mention 33, the tool tip should not touch the work surface while moving the tool from tool turret to coordinate number 3 or point number 3. Even if you specify 32, that is also correct, you will get the output. Okay. So okay, now I'll move the tool from tool turret to 33 comma minus 50. That is the start point of the tool for grooving operation. So next, use the grooving cycle. Use grooving cycle. Say grooving cycle is G75. Grooving cycle will be the G75 cycle. And remember the syntax for G75 cycle. Say syntax for G75 cycle is G75, R is retract. Remember this syntax, you need to remember. And next block I'll go to N20, then G75, I'll go to G75. You need to calculate what is the x what is the diameter of the groove. So what is the diameter of the groove? Look at the diagram. Look at the diagram. The diameter of the groove is 20 mm is given. Diameter of the groove is 20 mm. So therefore I will enter x is 20 mm. So the next one is we need to enter what will be the z value. What will be the groove length from the reference. I am repeating, groove length from the reference. That's very important. From the reference we need to enter. See, groove length is 5 mm. Suppose if you are taking from the reference, it is 5 plus 50. So that is 55, and it should be a minus sign. Because my reference is point 1 will be the coordinate number 1 will be the my reference. So that is groove length from the reference. So next one is you need to specify what is P and Q. P and Q, these are the pecking and stepping incremental distance in terms of microns. Let us assume, these are the assumption. I am assuming P is 500 and Q also I am assuming 500. Stepping and pecking distance in terms of microns, that is P and Q. And the last one is you have feed rate, you need to specify. So feed rate, I am assuming the feed rate, let us take 55 mm per minute will be the feed rate. Okay, so this completes the grooving cycle. Okay, so yesterday I explained till this point. So how to make, how to write the program by using rough turning cycle, and how to make the program, how to write the program by using G75 cycle or grooving cycle. So next one is, I'll go to next block, N21. Next is very important. Remember, this is very important. Now I am writing the program for thread cutting. Say I will use a different color. Okay, so that it is very easy to understand. So now from N21 onwards, I am writing. Okay, I'll use red color. So it is very easy to. So I will use N21, block number 21. From 21 onwards, I am writing the program for. Sorry, we need to send a tool to its home portion and call new tool, then start writing the program. So now I'll go to N21. So now send this tool to its home portion. So G28, U0 and W0. I send the tool to its home position. Then next one is after sending the tool to its home portion, call new tool. So that is M06 tool change. I am using T03. T03 will be the thread cutting tool. Okay, I am calling thread cutting tool. So now I will use the syntax. Now I will use thread cutting operations. Okay, so here before performing thread cutting operation, you need to specify. Which is the start point of thread cutting operation, where we need to start, from where we need to start thread cutting operation. So in this, just look at this diagram, so we need to start the thread from 2 to 3, from coordinate number 2 to TO2 coordinate number 3. So that will be the thread cutting operation. So start point of thread cutting is coordinate number 2. Therefore, I will move the tool rapidly from tool turret to coordinate number 2. Okay, so now the rapid movement. So G00 rapid movement of tool, and I'll move the tool from tool turret to coordinate number 2. So coordinate number 2, the coordinates are 32, 0. So now it is X is 32 and Z is 0. So this is the rapid movement of the tool where we need to start the thread cutting operation. So next I go to the next one, is very important. N24, only 2 blocks. Okay, see what is that cycle indicates? G76. It is G76 and P. Now look at the P value. What is for P value should consist of 6 digits. So what is the first 2 digits indicates? Number of finishing passes. So we need to assume, say number of finishing passes, I am assuming 0, 3. 3 finishing passes I am taking to make finishing operation in thread cutting, or I am using 4 passes to complete the finishing in thread cutting operation. We can assume, but I am assuming, say I am assuming 3 passes. For 3 passes, don't type 3. You need to take 0, 3. The first 2 digits indicates finishing passes. I am assuming. These are the assumption. You can assume any value, but don't assume 10 or 15 or 20. Let us take 02, 03, 04, 05 up to 05. Okay, maximum number of finishing passes I am taking 5 only. It should not exceed more than that. So now the number of finishing passes I am assuming 03. Then next 2, third and fourth Third and fourth digits indicates chamfer angle. See chamfer angle, what will be the chamfer angle of the thread? I think you are aware about chamfer angle, thread angle, you know these things. Yeah, I am assuming chamfer angle is, let us take chamfer angle is 0 degree. Don't take chamfer angle is 40. Don't take chamfer angle is 90, some other values. Even if you take chamfer angle 0, you will get the output. Okay, you will get a thread. So I am assuming chamfer angle is 0, 2. These are the assumption. That is the third and fourth digits. Next, if you go to fifth and sixth digits indicates thread angle. So anyhow, thread angle is not given in the problem. Assume thread angle is some 40 degree or 45 degree or 50 degree or 55 degree. These are the assumption. I am assuming thread angle is 40 degree. Is it clear? How we got p value? First two means number of passes. Next two means chamfer angle, and last two means it's a thread angle. Last two means it's a thread angle. Okay. So this is p value. Then after writing p value, the next step is you need to specify what is q. What is q? Q means minimum depth of cut in terms of microns. So you need to specify in terms of micron. This is an assumption. As per this cycle, we need to enter q in terms of microns. So q should be, let us take 250 microns. This is my assumption. You can assume 350 microns, 450, 500, 600, 700 or 1000 or 1500. These are the assumptions. So minimum depth of cut. While performing thread cutting operation, we need to specify minimum depth of cut, and that minimum depth of cut I am assuming in terms of micron, and it should be at 250 microns. Okay, so that is q value. Then if you go to the r value means is a finishing allowance. So finishing allowance in terms of mm. So what will be the finishing allowances we are giving? What will be the finishing allowances I am assuming to solve this problem. Say assume the finishing allowances I am assuming 0.2 mm or 0. Let us take 0.5 mm or 0.0 any value finishing allowance. I am taking finishing allowance is 0.2. So this is R is I am assuming 0.2. Will be the finishing allowance. So these are the assumptions. Okay, so this is the first block. Next, go to the next block. So next block is very important. So in the next block, we need to enter G76, X value, Z value, P value, Q value, and F value. So where X is core diameter, so we need to calculate what will be the core diameter. Okay, and also we need to enter. We need to thread length. Okay, we can enter the thread length is 50 from the reference, that is fine. And also we need to calculate what is the peak height of thread in terms of microns, and maximum depth of cut, that's the assumption, and F will be the feed rate. So now I'll go to some calculation part. So we need to do some important calculation for the thread cutting, and even in the examination you need to please show the calculation part. Okay, so now I will calculate what is the core diameter. So I'll calculate core diameter. Core diameter, and it should be x value. Core diameter means x value. So how do you calculate core diameter? So x is equal to, use the formula, x is equal to major diameter minus dia minus 2 into pitch. 2 into pitch. So this is the formula. So now I'll write x is equal to, so what is the major diameter? So look at the problem. Look at the diagram. M32 into 2.5. M32 means major diameter is 32 mm. So major diameter is 32. So minus 2 into minor pitch. So pitch is 2.5 is given. Now if you calculate, now I'll go to calculation part. So if you simplify these terms, so we are getting 2 into 2.5. So I am getting 5. 2 into 2.5 is 5. So 32 minus 5 is 27. So we are getting 27. So x I am getting mm. So this is the answer. Okay. So we need to enter x value is 27 mm. So next step is I need to calculate height of thread in terms of microns. Remember, it should be in terms of microns. Say height of thread. Height of thread. So now I need to calculate what will be the height of the thread. Okay. Height of the thread I will calculate. So height of the thread P. So P is equal to, you have formula. P is equal to pitch into pitch into 0.6134 0.61343 is the pitch, and we are getting P. I am getting the pitch is 2.5. Pitch is given 2.5 x 0.61343. So now pitch P is equal to, so now I'll do this calculation part. P is equal to 2.5 into 0.61343. So this calculation part. So we are getting 1.5335 millimeter. We are getting in terms of millimeter. So I need in terms of microns. I need in terms of microns. See, 1 millimeter is equal to 1000 microns. You know this formula. 1 millimeter, generally millimeter is greater than micron. So 1 mm is equal to 1000 micron. Just multiply by 1000. So now P is equal to, but just multiply by 1000. So if you multiply by 1000, you will get 1533 microns. Okay. So now we need to enter this P value 1533 microns. So this is the calculation part. So now I'll go here. I'll go to the next block. I'll go to the next block somewhere here. Yeah. Now it is N25. So next again the second block G76 x value. We need to specify x value. So as per the calculation part, x we are getting 27 mm. Fine, x is 27 mm. Then we need to take a z value. So z is thread length in terms of mm. Thread length is 50. Thread length is 50, and we need to take z is minus 50 because it is moving towards left side from the reference. Okay, and remember z value should be always from the reference. Z is minus 50. So then after that you have a P value. P is height of thread in terms of micron. Say we are getting in terms of mm and converted into micron. So we are getting 1533. See, don't enter 1.533. You will not get the proper thread. So thread height is 1533 micron. So that is thread height. Then after P, you need to enter what is Q value. So Q is maximum depth of cut in terms of microns. Say minimum depth of cut I enter 250. Let us take maximum depth of cut is 300 microns. It should be greater than first Q value 250, and here I will take 300. It should be greater than 250 microns. So Q is maximum depth of cut. And last one is for feed rate. I'll take feed rate is 10 mm per minute. Say don't give more feed rate while performing a thread cutting operation. Always try to give lesser value. F should be lesser value. Should be less than 10. Even you can give 5 also. Okay. So this is this completes thread cutting operation. Next, last step is check is there any other operations. If you don't have any other operations, send the tool to its own position and end up the program. So now I'll go to N26 I am sending this tool to its home position G28 0 and W0. Then I'll go to N27. So I'll send the tool to its home position. So that is, I already sent the tool to its home position. Now switch off the spindle M05, switch off the coolant M09, and end of the program with rewind. So it is a M30. So you can write M30 in the next block, or else you can write it in the same block. So I'll repeat N25. So it is N25, block number 25. Send the tool to its home position G28, followed by U0 and W0. So next block I'll go to N26. Switch off the spindle M05. Switch off the coolant M09. The program with rewind, so M30. Okay, so this is a complete part program for the given profile. Okay, is it clear? Any doubts? Yes, any doubts? Yes, Shamant, any doubts? Shamant, may I audible?
Yes, sir.
Okay, so better you can take the screenshot of this, take the screenshot. Those who are using mobile phone or laptop, you can take the screenshot. So this is for your reference, okay? So this is the program for this profile. See here in my laptop, I don't have software. If anybody has software, SIM software in your laptop, you can feed this program in the software and try to share your screen so that everyone is visible. We can cross check whether you will get the output or not. Or next, when if you say tomorrow or day after tomorrow, if you are attending the classes, or if you are coming to the class, so you can feed this software. You can feed this program in the software and try to check whether you are getting output or not. Okay. So take the screenshot of this slide. So this completes your SimLab. So I'll share some of the problems in thread cutting operation in practice. And tomorrow I will conduct internals. So tomorrow I will conduct internals at 9:30. Yes, have you taken the screenshot of this image?
Yes, sir. Yes, sir.
I will take the attendance. Okay, tomorrow you have internals, lab internals at 9:30, and this is for batch 1 and batch 2. For both the batches, I will conduct at 9:30. Okay, so remember, you need to use A4 size sheet, and I will give two programs. One is from milling and another one from turning. So everyone should switch on your cameras, and the duration will be the 3 hours. So you can write the program in A4 size sheet and upload in MS Team. And after that, I will prepare some for Viva question. I will prepare around 10 to 15 questions, and I will give the duration. Say maybe last 10 minutes. I will post the Viva questions, and duration will be the 10 minutes. So within 10 minutes, you need to complete the Viva. Okay. Those who are not attending Viva, so for them you will not get the marks, Viva marks. And those who missed the internals, I am not giving. I will not conduct once again the lab internals, and inform your friends, those who are. If you miss the internals, you will not get the IA marks. Okay. Is it clear? So tomorrow at 9:30. 9:30 means you should log in at 9:15. And the internals will start at 9:30. So I will share the questions at 9:30, and you can copy down that question and start writing. Is it clear? Any doubts?
Okay, sir.
Okay, fine. So now shall we wind up the today's session? Now it is 11 o'clock. So complete the records, and also you need to upload the record, whether it is corrected or not corrected. So you need to upload the scanned record in MS Team record. Better you can take a photocopy of lab record, and tomorrow you need to upload, not today. So I will share the link for uploading the record and attending the quiz. Okay, and also you need to upload the written program in the test or in the internals. So these are the things you need to consider. Okay, so tomorrow I don't have design labs. In morning session I don't have design lab, you have only sim lab for both the batches, for B1 as well as B2. Okay, inform your friends or inform your classmates to attend the internals. If not attending, I am not giving any extra internals. Okay, so now I will conclude the today's session, and we will see tomorrow at 9:30. Clear? Okay, thank you so much.